7.1 is angle relationships in triangles. Let's review some words that you should know. They come up in bits and pieces. So acute, an acute angle is like, oh, isn't that cute? It's less than 90, so it's smaller. A right angle is equal to 90 for sure, and the symbol is that little square box right there, the little square box in the corner. An obtuse angle is more than 90. An obtuse angle, so you can see how big this is. It's more than 90. This angle right here, more than 90. This angle here is acute. Okay. A straight angle has to equal, sorry, I think my video camera just died there for a second. I think we're okay. Has to equal 180, so equal 180. So a straight angle actually goes along a straight line, so it's this. And it kind of looks like a protractor, right? So a protractor, so you know for a protractor, it equals 180. What do I mean by protractor? This, right? So this is a protractor. We've seen that before. Right, so a protractor is this. So this goes from 0 to 180, which means this whole line, the whole straight line here. So if I was to do a straight line like that, this straight line, that's 180 degrees. This whole arc right here, which matches my protractor, 180 degrees. Okay, so that's a straight angle. So it's called a straight angle, equal to 180. A reflex angle is between 180 and 360. Look, it's a big angle like this. That's how big the slice is. So it's more than 180. You know, this is 180, the half circle, so it's more than a half circle. So that's called a reflex angle, and it's between 180 and 360. All right, some more definitions. A supplementary angle. Supplementary. Sounds like supper to me. Supper, which is kind of big. Supper is like big angle, and it adds to 180. So it's this angle here, this whole angle, this angle, plus this angle are supplementary. They add to 180. In contrast, a complementary angle adds only to 90. So it's like something that complements you. It's a very little thing, so it's a smaller thing. That means it adds to 90. So that could be this angle here plus this angle here adds to 190. Oh, sorry, 90, adds to 90. Okay, so this is a corner. This is a corner here saying that this adds to 90. This is the whole straight line, so it's going to add to 180. All right, what else do we have? We have opposite angles. Opposite angles are equal when the two lines intersect. What does that mean? It means that this angle here, I'm going to use a dot, equals this angle here. So these two angles here are the same. And this little angle here is opposite to this angle, so those two are the same. Only when the two lines intersect, when they crisscross. All right. Now, triangles can be classified according to the lengths of sides and measure of angles. So we can classify, triangles can be classified according to lengths and sides of angles. How do we classify them? Classify them by name. So we're going to name them. This one here is called a scaling triangle, which means nothing is equal on it. It's just three sides. Something different would be the isosceles triangle, which means there's two equal sides and two equal angles. So that means, looking here, these two sides are equal, which also means these two angles are equal. So this angle equals this angle. And if these two angles are equal, those two sides must be equal. That's an isosceles triangle. Okay, so it looks like an icicle. I used to think icicle is the same on both sides. Last definition here, for this row here, is equilateral triangle. That means all three sides are equal, which also means that all the angles are equal too. The angles are all going to be 60, 60, 60, and 60. All of those angles will equal 60. So this little angle here is 60, this little angle here is 60, and this little angle here is 60. That's what makes up an equilateral triangle. Equilateral means all three sides are equal, and all three angles. This next one says it's a right triangle. I need you to understand the word right triangle. That means there can be one right angle. We usually represent it with a little box there in the corner. So that means that that corner there is 90 degrees. 90 degrees. It's a right angle, right triangle. Okay, this next one here says the sum of the interior angles of a triangle is 180. So that means inside these three angles, the A and the B and the C, all three of those little slices will equal 180 degrees. Okay, and you should be able to see that for any triangle that will work. So if I take any triangle, so I'm just going to make a random triangle here. I'm just going to cut this paper, see, randomly, not measuring anything. I just took a random piece of paper. So I'm going to take this, and I'm going to cut it up. So I've got my triangle. So that's my triangle. I'm going to take all of these corners. So I'm just going to color in the corners. So see this corner, and then this corner. See, I'm just coloring in the corners, and this corner. So I want to cut those corners off. I'm just going to rip them. I'm just going to do this corner. See how I did that? The triangle, this corner, and this corner. So I take all three of those little corners. I took them off. If I put them back together, facing in, so that the blue, right where I cut them out of, are all together. Whoops. And I attach them together. See the blues match? And that makes a perfectly straight line. A perfectly straight line. And we know that a perfectly straight line, so you see how that's straight? That's a straight line. That's exactly straight like a ruler, right? So you can see that's straight. And that straight line measures 180 degrees. So when you put all three of them together, that will be 180 degrees. So that happens for every triangle. You take all the corners, put them together. So that's why they said that for any triangle, doesn't matter what triangle it is, this corner plus this corner plus this corner, A plus B plus C, will always equal 180 degrees. So that's where they got that little rule from. Okay, because it works every time for any triangle at all. So that was a random triangle that I drew. All right. Next one. So that's what this one is saying. Now, my next rule is the exterior angle of a triangle. So here I have a triangle, and I'm drawing it further out. Now, this one might be a little bit harder to see. So I'm going to copy this triangle here. I'm going to go this line, connects to this line, connects to this line. So these exterior angles, you can see that they're like strings. So if I was to pull this one tighter and pull this one tighter, I think it like a hood. So if you're pulling your hood tighter, and I have 3 strings, which would be a strange hood, I did the same triangle. I'm going to make it a little bit smaller. So say I'm pulling the strings out. So I pulled the strings. I'm going to still do the same lines. And if I keep pulling the strings, I can do the same lines, and I'm going to pull them tighter. What happens is that the hood gets smaller, right? So if you pull your hood strings, the hood gets smaller and smaller and smaller. And the tightest it can go is going to be if all the lines are touching each other right to a point. So if you did this one more time, and they touched at a point, what they found is that if you add all of these together, it makes a perfect circle. So if you tighten the string really, really tight, all of the outside angles are going to equal 360 degrees because it makes a full circle. And what do I mean by outside angle? I mean this one plus this one plus this one. So those 3 strings. So it's this one, this one, this one. Look, and we tighten it, and tighten it until this, and this tighten up together, and it makes 360. That's how they got the exterior angle. It's basically string. So if you tighten the triangle as small as possible, you're going to get that the whole C plus D plus E will always equal 360 degrees. It makes a full circle. So if you tighten up all those strings really tight, it makes one circle for all the exterior angles. That's the exterior angles. Okay, so now we're going to try to answer a few questions. So for this one here, if I use the tick marks, that means that these side lengths are the same. So that means that these side lengths are the same. If all side lengths are the same, I want you to classify the triangle, and then find the missing angle measures. So if all three are the same, this is called an equilateral triangle, which means equal. So it comes from the word equal, equilateral. All three sides are the same. If all three are the same, then that means that all of the angles have to be the same. And to add up to 180, it has to be 60, 60, 60, because we know that 60 plus 60 plus 60 equals 180 degrees. Okay, so we found all the measures. Here, if I give you two sides are the same, this triangle is called an isosceles triangle. Isosceles triangle. So that means only two sides are the same, not all of them. Now, how can I find the missing angles? These two missing angles have to be the same because it's like a tree. It's like maybe a roof or something very regular. And people say an icicle, but icicles aren't always exactly regular, but yes, same idea. So these two here are the equal, which means that these two lines are the equal. So I'm going to do 180 minus the 70, which gets me 110 degrees. But I have to split the 110 between them. So then I go 110 divided by 2 is 55. So I know that each one of these sides here is 55. Like that. All right, so that's equilateral, that's isosceles. This one here, the type of triangle is nothing looks the same, so we're just going to call this one a scalene triangle, a scalene triangle. And that means that nothing's the same, but we still know that it adds to 180. So I'm going to do 180 minus the 56, and then minus the 73. If we do that, then I will get 51 degrees. So that means x is 51 degrees. The questions get a little bit longer because then I can draw some of the lines out. I can crisscross them and do more than one triangle. You can see there's two triangles there. So here, I pulled one string out a little bit to make a nice straight angle. So that'll get me a straight angle. So to find the missing slice of this straight angle, and you're going to show the work, 180 minus 124, which gets me a beautiful 56. So then I know that this little angle here, this angle is 56 degrees. So when you're not sure what you're looking for, I just start to fill in everything that I can find. Eventually I'll get there. So when I get to this triangle, I have x 4356, so that means that x would have to be 180 minus the 43 and minus the 56, which gets me 81 degrees. So this appears 81 degrees. Some people do that differently, and what they do is they go, okay, but I did 43 plus 56, which gets me 99. And then they say, if this is 99, those two here, then 180 minus 99 would get me 81 degrees. So that's the same answer as here. Okay, for the next example, we're supposed to find the measure. Oh, I didn't even read the question. This is so bad. find the measure of ECD. E to C to D. And then the middle letter is the angle you're looking for, which was this. Oh, phew, I answered it anyway by finding X. Okay. The next one I need to find ECD. So walk from E to C and then turn to D. E to C to D. The angle that they're asking for is this one between the two arms that I just drew. So to get to that one, you're going to need the connecting triangle. So sometimes this triangle doesn't have enough information. It only has one angle. So I'm going to go here, and I'm going to find this missing angle here. How do I find the missing angle there? If I know two angles of a triangle, I'm going to go 58 plus 63, which is 121. And then you're going to go 180 minus 121 equals 59 degrees. Therefore, angle ECD is 59. And here I should say, therefore, angle ECD equals 81. Okay. How do I know that this equals it? Because they're opposite angles. Sorry, I forgot to mention that. So this angle here has to equal this angle here. Right here, they're the same because they're opposite angles. Sorry, I skipped a step. So that's why if I find this angle, I can find that angle. They're opposite angles. Right? And you can see that that holds true. So anytime they're opposite, they're growing and shrinking with each other. So ECD is 59.